Let's take a look at the questions on homework number 18. Single variable equations. The first practice lesson will involve some coefficients or constants that are decimals. Each of these equations can be solved using only one inverse operation. For this first question, the variable x is being multiplied by 2, and the inverse of multiplying is dividing. So we're going to divide both of these sides by 2, isolating our variable x, and leaving us with a 0.9. Use your calculator if you need to compute the math. Let's try another one. In this example, x is being subtracted by 3.4. The inverse of subtraction is addition, so we're going to add 3.4 to both sides. These are inverses, so they become 0. And over here we're going to add, we're going to get 20.5. In this question, you see the variable x is being divided by 6. The inverse of division is multiplication. So I'm going to multiply the left side and the right side by 6. I'm going to use my calculator to finish computing this. 6.7 times 6. 40.2, and we'll type that in. So you only need one inverse to complete each of these questions in the first topic. The second one will require all addition or subtraction, one step with addition or subtraction. So all of these will require only the inverse of that operation. For us here, 8 is a positive being added to c, so we're going to subtract 8 from both sides, giving us a -4. For this next problem, we're going to subtract 3 from both sides. And you might want to use a calculator to help you with these integer rules here, but the answer would be -8. Well, let's take a look at the next lesson. This one is requiring you to multiply or divide on either side. So don't forget, you're always going to concentrate on the side that has your variable. So 3 is multiplying the variable s, and the inverse of multiply is divide. And if you can't do the math, right, and this is what I mean by if you can't do the math, -2 divided by 3, -2 divided by 3 is not an integer value. It's a repeating decimal that goes on forever. And I don't want you to give me an answer in this format. So if your division turns out to be a crazy decimal like this, I want you to leave it in fraction form. -2 divided by 3 is your actual answer. Don't give me the decimal. All right, we're going to do the same thing here. Our variable's on the right. The coefficient is 4. We're going to divide both sides by 4. And again, 7 cannot be divided evenly by 4, so we're going to leave this as -7 divided by 4, and we're not going to convert it to a decimal. For this next one, we're going to use the inverse of division, which is multiplication. So we're going to multiply both sides by 9 here to get t is equal to 90. Same thing on the next problem. Don't forget to concentrate on the side that has your variable. So the variable is a, it's being divided by 4. The inverse of dividing by 4 is multiplying by 4. So I'm going to multiply both sides by 4, giving me a -24. All right, we're going to move on to fractional coefficients. This can be troublesome for some. Now technically, the opposite of multiplication is division. But we don't divide by fractions. Technically, this is what's happening, but we don't divide by fractions. We multiply by the reciprocal. And a reciprocal is when you take a fraction and you flip it over. So whatever used to be the numerator will now be the denominator, and what used to be the denominator will now be the numerator. So I'm going to keep the negative sign, but I'm going to flip the actual fraction. So 5/6. So I'm going to multiply both sides by -5/6. That isolates our variable. And then you can do this math yourself. Negative 5 times 2 is negative 10. And the 6 would multiply by the invisible denominator over there, which is 1. And then you could try reducing these by dividing by 2. Oops, I'm writing that incorrectly. By dividing by 2. And get negative 5/3. Or you could do the division on your calculator or the multiplication on your calculator. So if we have negative 5/6, we use our fraction button, negative 5/6, and then we multiply that by 2, and it's going to give it to us already reduced. So negative 5/3 is our response, and that's what we'll type in. So remember, the inverse, when you have a fractional coefficient, is to multiply by the reciprocal. So a negative 4/5 would flip over to become a negative 5/4. A negative times a negative is a positive, and 10 times 5 is 50, and 4 times invisible 1 is 4. And these are both even, so I know I could divide them in half, so it's 25 halves. I could probably write this as a decimal, since dividing by 2 is not an inconvenient decimal, but you can leave it as 25/5 if you'd like. So 25 halves. 25 halves is the right answer. You can also convert it to a decimal, but if it's given to you in fraction form, we typically want the answer in fraction form. All right, one last one. Remember, this is called a coefficient, and the coefficient is a fraction, and when the coefficient is a fraction, you multiply by the reciprocal. You flip it over, and you multiply by the reciprocal. Pick up your calculator if you need to. 9 times negative 4/5. So I'm going to type here 9 times negative fraction button 4/5, and I get negative 36/5. And I'm going to type it just like that. Alright, so that's how you solve it when you have a fractional coefficient, and some of these down here will also have fractional coefficients. Alright, let's take a look at this one. It's a two-step problem, and they're going to want us to use the inverse of the constant first, and the constant here for us is negative 1. The inverse of that is plus 1 on both sides. Bring down your variable term, negative 73 plus 1. Use your calculator if you need to. Divide by your coefficient, and get your final answer. So I used two steps in order to answer that problem. First step was getting rid of the constant. Second step is getting rid of the coefficient. So I'm going to do another one here. So my constant is negative 6. To remove that, I put plus 6 on both sides. Rewrite my problem. Divide by my coefficient. And get my final answer, which is 4. Okay, one more time here. Our constant here is 50. This minus sign, or subtraction sign, it belongs to the 11, not the 50. So the opposite of 50 is negative 50. And then I'm going to write negative a over 11 equals 8. So I'm deliberately going to take this negative sign and give it to 11. Because this is a division problem right here. Divide by 11, right? That's what that says. I'm going to give that negative sign to 11 so that when I do the opposite of dividing, which is multiplying, I multiply by negative 11, that negative sign can disappear. So a is equal to negative 88. So watch that sign and be careful. All right, two-step equations with fractional coefficients. We got this. So we're going to do something very similar to what we were doing before, and that is we're going to clear our constant first, which for us is the minus 12. So we're going to add 12 to both sides, and then we're going to get 15 is equal to 1/6 c. This is multiplying. The opposite of multiplying by a fraction is dividing by a fraction. So we don't divide by fractions, we multiply by the reciprocal. Now because this is 6 over 1, you could simply write just 6 when you multiply here. So C is going to be equal to 30, 60, 90. Let's try this one more time. Again, with the coefficient that's a fraction, we're going to subtract 8 from both sides. And then we're going to multiply by the reciprocal. In this case, I'm not going to write the over 1 because I don't need to. So I'm going to multiply both sides by 4, giving me a 48. All right, last topic, 3-step linear equations. So this one is new for you this year in 8th grade. In 8th grade, we learned that we can have variables on both sides of our equal sign. So this is our equal sign, and we have 2 terms on each side. So it doesn't matter whether we have the variables on this side and the constants on that side, or whether we have the constants on this side and the variables on that side. It doesn't matter. I prefer my variables on the left. It just feels more familiar to me. So I'm going to choose to remove the x from this side and make it come over here by doing add 7x to both sides. And conveniently when I do that, my x remains positive. Now I have a more familiar looking setup here with my constant that's going to be subtracted next, and my rewrite. And my final step, divide by my coefficient. Okay, so you cannot have variables on both sides. One of the variables you need to use an opposite operation for. So -4 is our answer, and then we'll try this again. Okay, so I have variables on both sides, so one of these I need to do the opposite of. It doesn't matter which one. So last time I did the opposite of the variable term on the right, so this time I'll do the opposite of the variable term on the left. Another reason why I chose to do this is because 5 is higher than 1, and when I combine these two terms together, I will get a positive x value. I prefer to have a positive x value, but it doesn't matter. Divide by my coefficient and get my final answer. Alright, do you need to see one more, or you think you're getting the hang of it? Alright, this will be the last one. Again, I have variables on both sides. It doesn't matter which one I do the inverse of. So I'm going to move 9x or remove my 9x this time because it will leave me with a positive variable. We'll subtract 4. I'll divide by 3. And I'm going to get my final answer of 6. Now, I'm going to back up and do this one more time, but this time I'm going to do it a different way. And this time I'm going to start by subtracting 12x, just to show you that it doesn't matter which variable you choose. The only difference this time is when I got to my last step, I had different signs with my numbers. But we both got a positive 6 as our response. Alright, that concludes our lesson for homework number 18.